Hello, in this video we will review DAE for BigQuery's data filtering and data segregation feature, which is one of the most useful features in NextLabs' DAE suite solution. This feature allows us to control what rows or records are visible to users when they run an SQL statement. The rows visible to the users are dynamically determined by comparing the attributes of the users with some of the values in the row. For example, the sales record keeps track of all the different sales transactions for the different branches of the organization. I want to create a policy that allows non-HQ users access to sales transactions only within their branches. We will need two policies to meet these requirements. First, we need to make sure that HQ users can access all the sales records. For us to do this, we'll need to create a policy that allows HQ user to select from the sales table. For the second policy, we need to create grants branch users access to the sales table. But this time, we have added an obligation, the predicate condition obligation. This obligation allows us to specify the conditions that needs to be met before a user is granted access to a particular row. Let's take a look at how these two policies will be defined in our demo environment. I have already prepared the first policy we need, which allows HQ users access to the sales table. Here, you'll see that this policy will return an allow effect for users in the HQ user group, and if they are accessing the sales component. Now I need to create the second policy. This policy will allow branch users access to the sales table. This policy will also return an allow effect, but this time for users not in the HQ user group. In addition, we could create a separate component for the branch users, but we can also just use the HQ user group and negate the condition. We are going to be giving the allow effect if these users are trying to access the sales table. And then we're going to add the predicate condition. Here, we can specify the condition that we want to use in this policy. We will put branch underscore name is equal to $user.branch underscore name. This condition allows us to dynamically compare the branch name attributes of the user with the branch name column of a sales table. Using a dynamic comparison, we don't need to create a policy for every single possible branch name. This makes the solution easier to manage. If you are doing this with a traditional role-based access control, you will need to create at least one role for each possible branch name, which is quite inefficient. With attribute-based access control, all you need is one policy. So let me save and deploy this policy. To see how the created policies will affect our test cases, let's start by running report number 3 as Tonny, which will allow us to see the basis of this report. Tonny, who is not restricted by any other policies, received 30 rows. Let's try to run the same report as Linda. Linda only gets 4 rows, and this time they're all coming from Madison Avenue. Let's try to run the same report as Joy. Joy only sees 3 rows in her report, and all the branches are coming from Lincoln Park. So how does DAE enable row filtering? Row filtering is achieved by adding a where clause in the statement. Let's copy the statement or the safe SQL statement. Now we can look at one for Linda and run this directly on Google BigQuery. This is the same result we got when we ran the same modified SQL from our reporting tool. You'll see here that row filtering is achieved by adding a where clause in the statement. and any dynamic attributes that were written in the predicate condition were replaced with the actual set of values for that particular user. Since we're running this as Linda, the branch name was transformed into Madison Avenue. And if we're going to run this as Joy, the branch name would be Lincoln Park. Now, when we are using row filtering, it is important to remember that when using mathematical formulas, only the rows visible to the users will be used in the formulas. For example, if we run report 2A as Tonny, you can see that this report returned 10 rows. You will also see the total sales for each of the branches and the grand total of all of the sales across all branches. Now, if I run this report as Linda, you will see that aside from Linda only having one branch or one record here, which is for the Madison Avenue branch, the grand total is also different from Tonny's. Here, the grand total is only 2,660, which is the sum of all rows returned for Linda. So the sum function in this query was only able to add the values that were visible to Linda. This will also be the same if we run this as Joy. The grand total that she has here is the grand total of all the branches that she has access to, which is only 880. So this is very important to remember when you are running mathematical formulas alongside policies that enable data filtering. This concludes our feature demo video on data filtering and data segregation using DAE for BigQuery. Thank you for watching.